Okay, for the chain rule, what he's going over in this first part is that the chain rule is like a composite function. For instance, let's say we had a function f of x equals 3x plus 1 squared. Well, really, this could be written as a composite function. Have you ever seen, well, like this? We're going to call it g of h of x, where g of x is x squared and h of x is 3x plus 1. So if h of x is the input to g of x, then we say this becomes g of 3x plus 1. So 3x plus 1 is now the input into g of x, so 3x plus 1 squared. That's what he's getting at when he shows you this type of example. He's saying, notice this, the rate of change of temperature with respect to height times the rate of change of height with respect to time will give you the rate of change of temperature with respect to time. Okay? That's how he gets this. That's where we're going over this chain rule, which is what you and I were doing today. So if I try to take the derivative of this here, if I want, I could say that u equals 3x squared minus 2x minus 5. Therefore, y could be written as u to the fourth. So I would find dy dx by finding dy with respect to u, and then u with respect to x. All right? So dy du equals 4u to the third, doesn't it? Which, if I substitute back in what u is, it's 4 times 3x squared minus 2x minus 5 to the third. If we come over here and take du dx, that's what? 6x minus 2. So that will go right here times what we have there, and our whole dy dx will equal 4 3x squared minus 2x minus 5 to the third times 6x minus 2. All right? Let's look at this. How can we find dy dx if y is the square root of 2x plus 1? Well, I'm going to do this. I'm going to say I'm going to call u e2x plus 1. So y becomes the square root of u, which when I do square roots, I like to write them like that because it's easier for me to differentiate. So dy du is equal to 1/2 u to the minus 1/2, right? Du dx is equal to 2e to the x, right? Because the derivative of e to the x is just e to the x. So dy dx is equal to dy du times du dx. Remember, I have to substitute back in for u here. So dy du equals 1/2 2e to the x plus 1 to the negative 1/2 times 2e to the x. And we could simplify, right? 1/2, this and this cancel. And I could write this if I want. E to the x remains in the numerator, and I'll move this down as 2e to the x plus 1. Okay? Let's try the next one. All right. Here we go. We have, I'm going to call u equals e, to the x squared plus 1. Actually, no. U is going to equal 2x plus 1, isn't it? So y equals e to the u. dy du is equal to e to the u, right? Which is, if I substitute back in, e to the x squared plus 1. du dx equals 2x, doesn't it? So I'm just writing out the long way so we see what's going on. dy dx equals dy with respect to u times du with respect to x. All right? dy du is this, which is e x squared plus 1. Du dx is 2x. So that's your answer. Now, maybe I don't necessarily have to substitute. I do like to, but what if I wrote it this way? Y equals x squared plus 1 to the 1/2. So I can say dy with respect to x is, first I do 1/2 x squared plus 1 to the negative 1/2, and then I do the inside, which is 2x, right? Simplify it. This and this go away. The answer to this one would be, we have an x in the numerator, and we have the square root of x squared plus 1 in the denominator. Wow, now this one is actually, we have an inside and an inside here, don't we? So if I take dy dx, it's going to equal, I should try to erase that, I don't know how to erase it. It's just e to the square root of x squared plus 1, right? Times the derivative of this thing, which is 1/2 x squared plus 1 to the negative 1/2, right? Times the derivative of this inside piece, which is 2x. Right? Because if I rewrite that exponent like this, isn't my derivative 1/2 times the parentheses to the negative 1/2? So this whole answer, if I put it together and I simplify, those go away. So in my numerator I have e to the x squared plus 1 times this x right here, all over the square root of x squared plus 1 in the denominator. All right? All right, let's look at this one. Dang! We have a few substitutions here. Right? Because y is actually e to the x squared plus 1 to the 1/2. So dy dx. First, I'm going to do the outside, which is this 1/2 e to the x squared plus 1 to the negative 1/2, right? Then I'm going to go to the inside. And the first part of it is e to the x squared plus 1. The derivative is e to the x squared plus 1. Then I have to go into the innermost part. And the derivative of that is 2x, isn't it? So I'm going to simplify again. The 2's cancel. All I have in the numerator is x. No, I have this too. X e to the x squared plus 1 all over this thing. The square root of e to the x squared plus 1. So it gets a little complicated. If you want to keep substituting, you can. But you can always start at the outermost to the next inner one to the innermost. All right? Now, basically, this is what he's saying there. He's saying, first, take the derivative of f, and then take, f of that g of x, and then take the derivative of the inside. So let's see what we have. Suppose that f and g are differentiable functions with the given values. Find the derivative of h when x equals 2 if you know this composition. Right? So what you do, here's x equals 2. So we first take g of x when x equals 2, and that's 4. So this becomes f of 4, right? And then f of 4 is 2. And then we want h prime. Okay, I didn't do that right. Let's try that again. I didn't do it right. Let's go back to what they said here. It's f prime of g of x times g prime of x. And notice x equals 2. So g of x, g of 2 is 4. So we'll do f prime of 4 times g prime of x. G prime of 2 is 6, isn't it? Now let's go back. F prime of 4 is 5. 5 times 6, that should be 30. It's a little funky, but that's what that is again. We just applied this rule right here. It's a little weird when you have to use numbers, but that's what we wanted to do. So if I just double check this, notice we had to start at the inside. So we said, what's g of x? What's g of 2? When x is 2, g of x is 4. So that goes inside. Then we're taking f prime of 4. Well, f prime of 4 is 5. And then down here, it's g prime of x. So g prime of x, when x is 2, is 6. So 5 times 6 is 30. So that should be good. So this is the chain rule video. I hope this helps. Thanks.